So this is the third chapter that we are going to cover from class 11 mathematics. Earlier we have covered chapter 1 and chapter 2, that is sets and relations and functions. So this one is going to be on trigonometry. It's a very important chapter, reason being there are many questions that are asked in many competitive exams directly from trigonometry. And moreover, it's a good concept from from the point of view of maths in class 11. So the idea is we will try to cover it in multiple sessions. There are going to be small sessions, right? And in each session we will try to cover some part of the theory, and along with it we are going to do some examples that's going to make the theory more concrete, right? So so with that idea, let's start with trigonometry. So we'll start with very basic what's an angle. So we all know what's an angle is, right? So for example the axis, right? And then when we start moving towards anti-clockwise direction, then we make an angle theta, which is the positive angle, right? And if we start moving downwards in the clockwise direction, then the angle that we make is the negative angle, right? So we have this, okay? So an angle is it's going to cover entire thing, so it can move till here, which in total gives you 360 degrees, right? And likewise it can move in a clockwise direction and can give you minus 360 degrees, right? Now it is not only limited to 360 degrees. This can further keep on moving, but after 360 degrees, it's effectively, if I am saying the angle is 400 degrees, then I know definitely the one circle has 360 degree has been covered, and after that I move 40 degrees. So there is nothing but equal to 360 degrees, that is equivalent to 40 degrees in counterclockwise direction, right? So this is what angle is, right? And it is measured in degrees. However, we have another measure which is called radian, right? So there is another measure of another unit of measuring angle which is called radian. So what happens is, in case of radian is, how do we define radian first of all, right? So let's take a unit circle, right? This is a unit circle, that means its radius is 1, right? Its radius is 1. Now what happens is, if I start traversing this arc and I move a distance of 1 unit here, right? On the arc also I move a unit of distance of 1 unit, then essentially when I reach to this point, then the angle that is subtended at the center is nothing but 1 radian, right? V-I-A-N, we call it radian. So it is essentially nothing but, in a unit circle, the angle subtended by the arc of length 1 unit onto the center is 1 radian. But this is not necessarily that it's going to be a circle of radius 1. So for that matter, let's generalize it. So if I have a circle of radius r, and if I move a distance of r unit here, then essentially what I am doing is, I am subtending an angle of theta. So when these three things, this side and this side becomes equal, then the angle at the center is nothing but 1 radian, right? Now from this we can derive many things. So I know that circumference is nothing but 2 pi r, right? This is something that we all know, it's a basic thing, right? Now what happens is, what is circumference, right? So this thing, right? So the moment I cover one entire circle, then the angle that I am going to do is going to be 2 pi. So it's going to be 2 pi. So what happens is let's say r unit gives an angle of 1 radian here. That means 1 unit gives an angle of 1 by r radian, right? That means 2 pi r gives an angle of 2 pi r upon r, which is nothing but 2 pi, right? So that means I can say that one complete circle, which is nothing but equal to 360 degrees, right, is equal to 2 pi. Okay. So I am saying, likewise we have 360 degrees as one circle. In radians unit, it's 2 pi. Okay. So what is 2 pi? So pi is 22 by 7. So what I can do is 2 into 22 by 7 approximately is equal to 360 degrees, right? So essentially 1 radian is nothing but 360 into 7 upon 22 into 2, which is approximately equal to 56 degrees and some minutes, right? And around 30 minutes, okay. So what happens is, what are these minutes now? Okay. So before moving into this, what radian is, I would just like to cover on a sideline note that what is degree. So one circle is 360 degrees, right? That we all know. Now what happens is, in 1 degree we have 60 minutes. So what happens is 160. So when I say 360 degree, so if I move 1 by 360th part, so this is 1 by 360th part, right? So when I move 1 by 360th part of the circumference, then I essentially move 1 degree, right? Now this 1 degree, if I divide by 60, so when I move 1 by essentially this divided by 60 times is nothing but equal to 1 minute, right? So what happens is I cover 1 by 360 of this arc upon 60th part is 1 minute, and then when I further move it by 60 degree, I move it like 1 second, right? So what happens is 1 minute is nothing but equal to 60 seconds, right? So that's the way it is. So one circumference is 360 degree, 1 degree 60 minute, and 1 minute is 60 seconds. Okay. Yeah. So that's the conversion. So this is very critical conversion, and we might have to remember it. So from here we can derive a formula till now whatever we have discussed. The formula goes in this way. Okay. So how does the formula go? So as I mentioned, when we cover a distance of r unit in r radius, r units of circumference around a circle with radius r, then I cover an angle of 1 radian. So what happens is I can say theta that I subtracted at the center is nothing but L upon R, right? So what happens is when I say so when I say that this is a circle, right, and I am covering a unit of L here, right, L unit here, and the circumference and the radius is R, then what happens is the angle that I subtracted at the center is nothing but equal to L upon R radians. This is now all moving in radians, right? So clearly we can see that when L is equal to R, then I am putting it at 1 radian, right? This is again the same thing that we discovered earlier. So this is nothing but theta separated by an arc of length L on a radius R is, they are connected. Okay, theta is equal to L upon R, right? So that's the ratio of the circumference that is covered on around a circle of radius R. So what essentially is a relation between the linear line, the real axis, and the circle, right? So this is 0, say suppose, and this is 1, and this is, say suppose, 2. Okay. Now we have a circle. We have a circle of radius, 1. So how it's going to go? It's going to go somewhat like this. Okay. Oh, this is not a. Actually, this is not a circle. So let me draw it again. Okay. So how will it go? It's actually is going to go like this. So let me draw it in this way. So this is a circle. Okay, this is a circle, right? And let me draw a real line. Okay, this is going to be 0. This is the circle center, and let's call it as 1. So let's see the real line, right? So real axis. Okay, this is -1. So what I'm saying is, this is real line. Okay, this is real line, and this is unit 1. And likewise, this is nothing but if I curve this line, then we are moving in a circle. So this real line and the circumference and all theta is equal to L upon R, these are all related. So it's not we are looking at something different. It's just like the real axis is now converted into here, right, in this way. Okay, when I move 1 unit here, that means when I move 1 unit, so when I cover it, it's like this. So then this point will be somewhat here. Say suppose it reaches here after covering, right? So this is nothing but it's going to subtend an angle of theta is equal to 1 radian. So I said the radius is 1, then this line where it will go, so this is 1 definitely. So what I'm saying is this is going to be 1 because I have turned this up. So this angle is nothing but 1 radian. Okay. So these are sort of connected concepts. It's not we are looking at something else. It's like a number line which is almost like curved and it has been banked into a new circle, right? So okay, so that's here. Now, okay, so saying here, so as I mentioned, 1 radian is nothing but equal to 57 degrees and 16 minutes. So 2 pi radians is equal to 360 degrees. That means 1 radian is 360 upon 2 pi, which is nothing but 57 degrees and it's 16 minutes, right? So this is correct one, right? This is the correct approximation. 57 degrees and 16 minutes. Okay, so this is here. Now, conventionally, so let's take some example here. Okay. So the example says, let's take a few examples. So the question goes in this way: find the radius of the circle. Find the radius of the circle. So there is a circle, right? Find its radius. Okay, we have to find A, in which a central angle of 60 degree intercepts an arc of 37.4. So what I'm saying is, and this is like 60 degree. Okay, substance. So this is the center, and this the length of the arc is given. This is 37.4. 37.4. So what they are saying is, this arc subtends an angle of 60 degree. Now first thing is, let's convert 60 degree into radians. I know 360 degrees is 2 pi. That means 60 degree is nothing but 1/6. So 2 pi by 6. This is nothing but equal to pi by 3, right? So this is nothing but equal to pi by 3. So what I'm saying is, pi by 3 radians is this, right? Now what I know, theta is equal to L upon R, right? So L I know is 37.4. It's 37.4 because length of the arc is L and the radius is of course A, like that we have taken, and the theta is pi by 3. So it's direct. A is equal to 3 into 37.4 upon pi centimeters. So if it is in centimeters, so it's going to be in centimeters, right? So simple, like theta is equal to L upon R, the net formula, right? This concept is used many times. So at some point of time you might say that an ant is moving on a circle and all those things, right? So it can be converted into different languages, but the concept remains the same, that theta is equal to L upon R, right? Trigonometric functions. Okay, now since we are now well aware with the concepts of angles and all, now we are going to move into trigonometric functions. So typically what happens is, for understanding trigonometric functions, which are like sine, cos, tan, cosec, we all might have heard, right? So we have studied in class 9 and class 10 what are the different sort of functions. So now what we are going to do is, we are first till our earlier understanding of trigonometry, we were just limited to triangles and like to right angle triangles, right? So there was one angle was 90 degree, then some angle was 30, 60, 45 and all those, right? Some standard angles, and then we were doing was height and distances problem, right? So what happens here is, we are going to make it a more generalized concept. So the angle could be any number, right? So it could be -40, it could be 360, it could be 720, it could be 1040. So any number, right? So what does it mean, like when we say about those angles, right? So this is going to be a generic concept. Now what happens is, for that to understand, let's draw a unit circle. Okay, so now again, this is a unit circle, a bigger one. This is the center. Now this is the radius, right? So it's of course 1 because it's a unit circle, right? Now what happens is, for that I'll let me pick up the red pen. So what happens is, so what happens is, now there is a point. So suppose I move theta from here. Okay, I move theta from here. Okay. Now let's say, what is the x coordinate? So at this point, which is for this point, right? So what I do is, if I move downwards, so this is my x coordinate. So these are my coordinate axes. So this is my coordinate axis, right? These are my coordinate axes. Okay, these are my coordinate axes. Okay. Now what I'm doing is, I'm essentially traversing. So somebody is moving here, like from here to here. Now I reach to this point, which is point A. So this is my y-axis, right? This is my y-axis. Okay. So now we know the trigonometry, and I know what is going to be this distance. So this is 1 at unit circle. So I know this is what? This is cos theta. Right? 1 cos theta. This is something that we already knew. And this line is nothing but equal to this line. It's nothing but sin theta, right? So what happens is, now this is my origin. This is my 0, 0. Now I'm moving here and I reach to point A. So I know now this point A has a coordinate. What's the coordinate of this point, right? So x coordinate is cos theta, right? Is cos theta, and the y coordinate is nothing but sin theta, right? So it's there. So what we are saying is, this cos theta and sin theta is nothing but so the coordinates. So if I can take as this cos theta and sin theta is nothing but coordinate of a point which is moving on a circle, right? It's moving on a circle. So what's the coordinate? So say suppose I quickly move on to say another new point, right? So now I move to say this point, okay? So I quickly move to this point, okay? Now this is the new point, and this is where I am, okay? This is where I am, okay? Now what's the x coordinate? Of course, so the x coordinate, let me draw like this. This is my x coordinate. This is my x coordinate, and what is my y coordinate? It's going to be like this, right? It's going to be like this. Okay. So the x coordinate at this point and this point are going to be sine alpha. Sorry, it's going to be cos alpha. The x coordinate is cos alpha and y coordinate is sine alpha, right? And what is alpha here? This entire angle is alpha. This entire angle. This angle is alpha, right? Now this angle is alpha. Okay. So what happens is, when I traverse a distance alpha, then cos alpha and sine alpha, right? So simply take it as like sine theta and cos theta is nothing but like the coordinate of a point that is moving on a circle, right? So that is sine theta and cos theta. Now we are more than happy in studying these two angles, right? These two functions, like these are the function of theta. Why? Because sine is a function and which is applied on a variable theta, right? So theta is variable, like it can move here and there, and there is a function which is like cos theta and sine theta, which is coming out, right? Okay. Now, are we really happy? But no, not exactly, because there are different functions further which are derived from this that we can study, right? For example, there are tan theta and cos theta, right? Okay, we will move to that, but before that, like quickly see just one thing. Like we know Pythagoras theorem, so I know the Pythagoras theorem. This is 90 degree. So what I know is this is square plus this is square is equal to this square. A square plus b square is equal to c square. Now what is this? This is cos square. So cos, this is cos theta, right? So I am saying cos square theta. Now what is this length? This is sin theta. That means I am saying sin square theta. A square plus b square is equal to c square, and what is c square is 1. So it's simple. So this is good identity now. What I am saying is this point which is moving on the circle, the point that is moving on a circle, its coordinate are given by the function cos theta sin theta, and that too those functions are not completely random, right? At any point of time they follow some identity. If I somehow know the sin theta, the y coordinate of the point, it's moving here. Like so, let's see how the point is moving. It's moving up like this on y-axis, right? The moment the point is moving up, it's moving up. The moment it's moving down, it's moving down. So y-axis is moving like this, and x-axis is moving like this, right? So it's moving here, it's moving here, it's moving here. When the point is here, the point on x-axis is moving like this. So it's doing a sort of a SHM here and sort of SHM here, right? So, but at any point if I suddenly stop everything, right? So it stops here and it stops here, right? Say suppose, then I know that they are not going to be random points. The square of this plus the square of this is going to be 1 at any point of time, right? So that's a good identity. Cos square theta plus sin square theta is 1, right? Now, what I said was earlier that I am not very much happy with only sin theta and cos theta. I am very much happy with many more functions, right? So one of them is tan theta. Now, if I know that coordinates are cos theta and sin theta, that at any point of time, can I take the ratio of those, right? How big is the y coordinate compared to x coordinate, right? So I'm saying how big is the y coordinate as compared to the x coordinate. For example, if I am at this point, so suppose I am at this point, right? I am at this point. So I know my x coordinate is very big as compared to y coordinate, right? This is the length of x coordinate, but y coordinate is only this much, right? It's very small. So there is a ratio as well. So I know that this and this, essentially the square of this plus square of this is 1, but I am happy in taking the ratio as well. So what I am saying is if I take the ratio of the y coordinate and x coordinate, right? So this is why, and that ratio I start calling tan theta. I'm more than happy in studying tan theta because there are many things that will come out from tan theta. So this is nothing but equal to sin theta by cos theta, right? Okay. So there is the ratio that we are taking. Now when we are studying a function, so when we know a function, then we are more than happy to study its reciprocal multiplicative inverse, right? What's a multiplicative inverse? That is like when I multiply that, then I get a 1, right? So I'm happy to study the multiplicative inverse of sin, cos, and tan. So we get another functions like 1 upon sin theta, okay, 1 upon cos theta, and 1 upon tan theta, right? So these are the functions in which I am interested, okay? So we start calling this as cosec theta, we start calling it as sec theta, and we start calling it as cot theta, right? So there are different functions for theta that we are interested in, and perhaps these are the functions that we are going to study in more details, like how do they behave, what are their, so since they are functions, they are going to have a domain, they are going to have a range, they are going to have a graph that we studied earlier in previous chapters. So they will have their own graph, they might have some cyclicity, they might start repeating at some point of time, right? So all these things we are going to study about this, right? Let's find some values of some critical, functions, okay? Critical values. So again, drawing a unit circle. Now I am saying of cos theta, cos of 0. Now, what is cos of 0? So I know what I am saying is cos of 0 is nothing but the point has not even started moving. The point has not even started moving. So what is cos theta, by the way? It's the x coordinate, right? So what's the x coordinate at this point, right? So if I draw the coordinate axis, right? If I draw coordinate axis, I know the x coordinate is 1. It's a unit circle, right? So I know cos 0 is 1. It's a good angle, right? Now likewise, can I find sin 0? Of course, it's like direct. If the x coordinate is 0, first of all, I know this square plus this square is 1, so this has to be 0. But more than that, I can see the y coordinate. Y coordinate here is 0 because it has not started moving up, right? So sin 0 is 0, so cos 0 is 1, right? Likewise, if I start looking at cos of pi by 2, now what is pi by 2 is? First of all, 2 pi is 360, pi is 180, so pi by 2 is 90. So what I am saying is I am standing at this point 90 degree, and I am standing at this point, right? I am at this point, I am standing at this point, right? So I am standing here. Now what I am saying is at this, what is the value of cos theta? Cos theta is nothing but the x coordinate, and I know the x coordinate here is 0, so this is going to be 0. And likewise, sin of pi by 2, which is y coordinate, is going to be 1 because it's already standing at this point. This is the y, right? So there are some good angles that I know directly. Okay. Now likewise, can I find something of cos of pi? Can I find what is cos of pi? So I know pi is 180 degree, so I move here. So essentially where I am standing is I am standing at this point, right? I am standing at this point, which is 180. So at this, what is the x coordinate, right? First of all, what's the x coordinate? Because cos theta is the x coordinate. I know I am standing at this. This is now negative. I am on, this is origin. I am on the left hand side, so this is negative. So this is nothing but minus 1. Right? Likewise, sin of pi, nothing matter. Negative positive, it's 0, right? It's 0, right? So sin of pi is 0. Okay. Now 3 pi by 2, again standing here. So cos of 3 pi by 2, that is 3 times 90 degree and 270 degree. So I am standing here. So this is nothing but y, the x coordinate is 0, and sin of 3 pi by 2, which is y coordinate, is nothing but minus 1, right? This is there. And when I make it 2 pi, so what happens is cos of 2 pi. So cos of 2 pi, I draw a complete circle. So the x coordinate again becomes 1, and sin of 2 pi, it becomes 0, right? So y coordinate. So there is one interesting thing that we can see, right? If this is the coordinate, x coordinate and the y coordinate of a point which are moving, so the moment a point comes here, it comes here and then it crosses here. So what essentially happens is, it's standing at the same point, right? It is standing at this angle, right? Theta angle. So what happens is, if any angle crosses 360 degree, then again we start a new circle. And the x coordinate and the y coordinate start repeating. So this is nothing but like a sort cyclic function that we can see. It's a cyclic function. Okay. So this is since sin and cos value are starting to repeat, therefore all the angles like tan, cosec, sec, and everything, cot and everything, they are going to start repeating themselves, right? So at this point of time, at least I can say their cyclicity is 2 pi. After 2 pi, they are going to repeat themselves, right? So that is something that we can fairly say at this point of time just by our knowledge, right? Later on we will see that there are functions which have cyclicity of pi as well, right? So that's there. Now before moving ahead, okay, so one of the last points for this video perhaps. So when is sin x equal to 0? So let's say when is sin x equal to 0? Okay, that's it. I'm saying sin of x is equal to 0. Now what does this mean first of all? It means that the y coordinate is 0. So when is the y coordinate 0? I start moving here, no, it's 0, right? So I know at this point is 0. Okay? So it's like at 0, it's 0. I start moving and nowhere it's going to be 0 unless it reaches this point, right? Which is pi. Right? And then again I start moving and it reaches 2 pi. Right? And then again start 3 pi, 4 pi, and so on. So what I can see is series is n pi. So sin theta is 0, then that means x is equal to n pi. So for all multiples of pi, sin's value is 0, right? Now when I say cos pi is 0, cos x is 0, then what happens is, now let's see, where is the x coordinate 0? It's not definitely not 0 here, but it's 0 here, right? And it's 0 here, not 0 here. So at this point it's like moving to 0, right? So x coordinate. Now what is this pi? So this is like, let's say pi by 2. Pi by 2. Then this is 3 pi by 2. Then 4 pi by 2. Then 5 pi by 2. Then 7 pi by 2. Can we see a sequence here? 1, 3, 5, 7, these are odd numbers, right? And the multiple is pi by 2. So how do we represent odd number? Is 2n plus 1, right? 2n plus 1, pi by 2, right? So what I am saying is, why do I write 2n plus 1? 2n is going to be even and plus 1 is going to be an odd. So I am skipping one number in the natural number starting for odd. So if I have x is equal to all odd multiples of pi by 2, then cos theta is going to be 0. The x coordinate is going to be 0, right? So I think for today's lecture, at least we can recall these things. So quickly summarizing the lecture, we know now how to convert a theta into radians, the conversions, minutes, seconds. We know what's the definition of theta, like it's the angle subtended by an arc. Theta is equal to L upon r. That also we know. Now we know what's the meaning of the function sine, cos, sine and cos. They are the x coordinate and the y coordinate of a point moving on a unit circle. Then we are not happy in those functions. We want more, so we started taking their ratios, their multiplicative inverse, and then we have multiple functions, right? Then we know somehow how to find values of some good ratios, some good angles, and then we can visualize it just by looking at the diagram, right? So this is all right for this video. In the next video, guys, what we are going to do is we are going to cover something around the signs. So the sign are going to change, right? If I am here, then this ratio might be positive, negative. That we are going to see, and we are going to cover some the domain and the range of the functions along with their graphs, right? So guys, please keep watching, and thanks for this video. Thanks.